Okay, the year 11s, we're going to do a quick sketch of each of these examples here. Let's do A together. So in A, what I can see is that I'll be reading the transformation, and we can see that there is no vertical translation or horizontal translation, so it doesn't move left to right, up or down. What I do see though, there is a dilation factor, but no one really knows what that is. So it just means I'm going to find my y-intercept. So that's when x equals 0, and we're going to solve for y. So that tells me y is equal to 2 times 3 to the power of 0. 2 times 3 to the power of 0 is 1, so then 2 times 1 is 2. So that tells me that the y-intercept must be then at 0, 2. And I know that the original asymptote is still at y equals 0, so the asymptote hasn't changed. I'm doing a dotted line. I ruled it. It's y equals to 0, and I'm going to sketch the graph as the same shape as it should be. The only difference is the y-intercept is now at 0, 2, so I need to label it as 0, 2. Okay, so that's part A there. Let's do part B. Part B, same idea. I'm just going to draw out my graph. So here we go. This is my graph, and what can I see from this graph? Again, there is no vertical or horizontal translation, so that means the asymptote is still at y equals to 0. So I'm just going to draw a dotted line there, and that's still going to be y equals 0. And I know that that 2 there just means that it's a compression by a factor of 2, so dilation of factor half from the y-axis. Right now you probably won't know what that means, but it just means it compresses towards the y-axis. So again, that only changes the potential y-intercept. So let's find out what the y-intercept is. Y-intercept is when x is 0, and you'll find here, this will be interesting, when I let x equal to 0, can you see that this now still becomes 1, and therefore 0, 1. So the y-intercept is still at 0, 1, and this highlights why when you do, whether you change this number to 10 or whatnot, it doesn't change the y-intercept. The y-intercept still stays the same because you're always multiplying the x by 0, and so it will always be 0, 1. But you'll see the difference in the shape of the graph. They'll go like this, they'll go like this, but they'll all cross through the 0, 1. Okay, so it gets steeper or flatter, but it's still at 0, 1 as the y-intercept. Okay, so there we go. That's my graph there for part B. I'm going to label y and I'm going to label x there. And then I should do the same for this, y and x. And then doing C, let's have a look at C, example C. We've now got negative 3 to the power of 2x plus 4. So that plus 4 there tells me that I'm moving up by 4. So asymptotes move up to by 4 now. There is a negative, so reflect in the x-axis. And that's about it. So all right, so we've got y equals to negative 3 to the power of 2x plus 4. What does the shape of the graph look like? Let's do it again. So I'm just going to draw out my shape. Here we go. We know that the asymptote has moved up by 4, so I'm just going to do this, up by 4. I'm going to label it y equals to 4, and there's a reflection, and I also need to know the y-intercept. So y-intercept is when x is 0. So here we go, y is equal to negative 3 to the power of 2 times 0 plus 4. That becomes negative 3 to the power of 0 plus 4, which is negative 1 plus 4, which is 3. So therefore, it is at 0, 3. And that just means that, whoops, that was a poor graph there. It's not really perfect there. There we go, but that probably doesn't look like 3. This probably looks more like 3. I'm just going to draw the graph once more. Yeah, I'll go with that one. 0, 3. Okay, and technically we're meant to find x-intercepts, but at this stage you're probably, since you haven't learned logarithms, you'll leave it as it is. And there you go. That is the shape for A, B, and C. So I'm just simply finding y-intercept and the shape or the direction and labeling the asymptote, okay, based on reading the transformation.